from the fundamental operator of vector calculus, or the main operator, which is the gradient operator. As you will see, the other operators, such as the curl operator, the divergence, will all be extracted from the gradient operator. The meaning of the gradient operator is the change of something in space. For example, the gradient of the scalar, when the gradient of the scalar is 0, it means that that quantity is uniformly distributed in the space. The component of the gradient vector, as you can see here, which is shown by the nodal operator, this vector is called the del operator also, is composed of 3 partial derivatives with respect to 3 coordinates of space. This is written in Cartesian coordinate. You can see if the gradient of something is 0, it means that all partial derivatives of that quantity with respect to all 3 coordinates are 0. It means that it's uniform in all points in space. For example, if the first component is non-zero, it means that that quantity just changes in the x direction. The other directions do not affect that quantity. The del operator, or the nodal operator, or the gradient operator, shows the direction of change of something. When it is positive, it means that the quantity increases in that direction. And when it is negative, it means that that quantity is reduced in that direction. For example, the pressure gradient, which is a vector, is one of the most important vectors in dynamics. The pressure gradient is positive. When the pressure gradient is positive, it means that the resulted force from the pressure is negative, because the force is applied, is exerted from the high pressure to the low pressure region. As you see, I ask you to compute the change of a scalar. For example, I say about temperature. Let's speak about temperature, and I ask you to compute the change of temperature. You have to ask one question: in which direction? I have to tell you to compute temperature in x direction, for example. If you don't ask me that question, you have to present 3 components of change of temperature in 3 coordinates. So the gradient of temperature is a vector containing 3 components. Again, if I ask you to compute change of velocity, which is a vector, you have to ask 2 questions. First, in which direction and which component? If you don't ask these 2 questions, you have to present 9 partial derivatives of 3 components of velocity with respect to 3 directions. So the gradient of a scalar is a vector with 3 components. The gradient of a scalar is a matrix in the order of 2 and 9 components, and so on. So, as a general rule, the gradient operator always increases the order of its input. For example, I have written here the gradient of velocity, or any other vector field. The components of that vector field are u, v, and w. As you see, the gradient is a matrix with 9 components. The gradient acts on the first row of the drum. As you see, we have the partial derivative of u, partial derivatives of u with respect to 3 coordinates. The first row of the matrix is the gradient of the first component of the velocity. The second row is the gradient of the second component of the velocity, and the third law is the gradient of the third law of vector field. No other points. This is the gradient operator, always increases the order of its input. Okay.